Great. So welcome to the DevOps-Exchange August edition, virtual once again. Thanks for attending, everyone. So I will be your fabulous host for this evening. And if it didn't hurt to have me on screen as well, there's a nice mugshot on the screen there for me as well. So I'm Dan Campbell. I'm LinuxRecruit's lead consultant, and I also run the DevOps-Exchange Bournemouth. So basically, what are we? For anyone who doesn't know, we are a group of localized meetups across the globe. We've got meetups in the UK, Europe, and America. As I mentioned, I run the Bournemouth one, and there's a good kind of overview of the other ones that we run as well. Speaking of which, we're about to launch another one in America. So you might have seen Tony post on LinkedIn earlier, but we've started a meetup in New York, which will be starting quite soon, and have a few meetups to announce in the next few weeks, which is great. And if you are on Twitter, could you please join in and follow us at the Docs Hub and hashtag Docs with any questions, interests about this evening's talks, things like that. And if you can't catch, or any of your friends can't catch today's talks, then we're on YouTube, and the talks will be uploaded probably tomorrow first thing for everyone to have a look at. Great, so on to tonight's agenda. So we've got three great talks, starting off with Manuel from CloudBees, who's going to do a talk on digital transformation and microservices. And then we've got a bit of a tag team talk in the middle there. So we've got Barak from Bridgecrew and Corcoran from Slalom Consulting doing a talk on how to write a secure Terraform module. And then finally, we've got Christian from Millennium Management, who is talking about validation with Saltcheck. Cool. So if you want to get engaged within the talks, there's obviously a Q&A function on your screen. So at the end of each talk, I'll cherry pick 2 questions and get the kind of speakers to answer those for you live on air. And yeah, we'll get that done just right at the end of each talk. And of course, as always, we couldn't be kind of here without all the sponsors that we have to help us do these events. So I work for LinuxRecruit. LinuxRecruit are our major sponsor. We're a recruitment company. Not yet I ran that down your throat, but we're a community-focused Linux and DevOps consultancy. So if you do need any help with your company or looking for new things, then get in touch. And yeah, if you think you can do better than the people that are talking tonight, then get involved. We're always looking for speakers. So drop us a kind of message on Twitter or an email to any of the guys that run the events, or Ashley, who runs everything on the community side, and we'll get you involved. So yeah, I think without further ado, Manuel, if you're ready to take over, we can pass on to the first talk.
Okay, thanks, Dan. Just trying to share my screen.
No worries.
Okay. So should be able to share the screen. Okay. Thank you very much. So we'll try to do something which is quite quick about digital transformation, microservices, multi-cloud. It's more of thinking, more of a thoughts on the experience that we have in CloudBees and how to remove the anxiety when we see companies doing this digital transformation. Very first thing, very quick, and don't laugh when you read that. Software is eating the world. I'm using it, brief introduction of myself. I'm using it because I had the chance to work with Mark Andreessen. So I like that quote. And even though everybody uses that quote, I've done companies like Serena Software, HP, Opsware, CAS Software, CloudBees right now, just to say that I have, usually on LinkedIn, you see things like 20+ years. It's just to say many more than 20 years in the software industry. So I've seen a lot of things, always around DevOps, even though it was not called DevOps when I started to talk and to think about that. But the problem, more or less, is always the same. Since the very beginning, building and releasing software is complicated. You see here some kind of spaghetti stuff that you see in a lot of presentations. multi-tools, multi-processes, and multi-teams, where there is some disconnect on that. So if we want to dig a little bit more on the disconnect means that we have scale, complexity. If we want to deal with some companies, we are dealing with the biggest banks of the world in CloudBees. So we know what multiple revenue generating commercial companies mean, and we find usually hundreds of processes, hundreds even of tools. Okay, we're not talking only about Jenkins, Git, Terraform, Ansible, and Jira. We are talking about hundreds of tools. Some of them are internal, some of them are very old. They have been reworked with some bespoke changes and so on. And the problem is that there is a legacy on that. There is a legacy, and the companies do not want to remove these tools, to let these tools behind, even though they are working, they are moving towards microservices, clouds, nice architecture, nice infrastructures that should allow to save money, time, but at the end of the day, that add to the core, add to the complexity. So we don't have the visibility we want, and we introduce some risk more than anything else. Some of the companies have tried to replace all that core by a giant all-in-one system, but it's completely an anti-pattern. If we think about DevOps, if we think about software development, before the DevOps principle were here, it's completely an anti-pattern. So if we want to sum up in 2 slides, in a perfect world, we have this. We have Jira, Jenkins, Selenium, Quality Center, maybe, and we are building something that we will push to Kubernetes. In the real world, in the reality, it's not this. We have multi-clouds, we have multiple tool chain, multiple companies also that were bought. I am the example in CloudBees. I mean, CloudBees has bought last year Electric Cloud and Rollout. If you are interested in the movements in the software world, so this is the reality, and this is what we are trying, what we want to manage in the real world. So for that, to build a realistic view, we are talking about software delivery. Software delivery is something that the Gartner, Forrester, all the analysts are building at that very moment, 2020. It used to be CI, it used to be then CD, then release orchestration, and now they are moving towards this notion of software delivery, how to deliver the software, whatever the technology, but obviously it applies especially to the new, the modern infrastructure, so microservices, Kubernetes, clouds, just to name, just to fire some words like this. So software delivery, this is what we are talking about. What we like to do is to position software delivery. Where are we? Okay, in the DevOps world, in the life cycle of building and delivering applications, we are in the middle of Dev and Ops, roughly from a developer commit until the monitoring and operation into production. And software delivery manages or wants to manage both the applications, what will be deployed. So applications means everything that you can design, build, and push to production, and also the relying infrastructure. So the target machines, clusters, clouds that we will want to do. A small definition of the Gartner. the definition they are currently elaborating. The combination of deployment automation, so what the technical aspect of how to deploy a container, a microservice on a Kubernetes cluster, for example, the pipeline and environment management, what will be the different stages of my pipeline, how shall I release the applications, how I will manage what happens in the different environments, and at the end, release orchestration, so how to orchestrate all that spaghetti plate that we were seeing at the very beginning, and to orchestrate everything that happens. The benefits, I leave it on the recording. It's quite obvious, better quality. We go faster and we have a better high-level view, so governance, because we want to scale the release activities. And this is exactly what we see. If I want to pause a little bit before talking about the three ingredients, this is exactly we see in the customer, the banks, but also other types of companies. But banks are a very good use case for us because they are currently, I mean, at least 70% of the banks in the world have done the same choices in terms of processes, in terms of technologies. They are moving towards microservices. It's complex because where they have the flexibility of APIs and developing with microservices, they lose that flexibility when it comes to manage the releases more frequent, manage the dependencies between these microservices. At the end of the day, it's very difficult to do that. So what we want to do is, in several colors on my slide, is decouple the deployment automation and the environment management from the pipeline and the release, which means that we have a pipeline that defines the different activities that we want to do in the different stages. And the actions of deploying the microservices on which target I want to deploy the microservices are decoupled from the definition of the pipeline, which means that if I want to have a multi-cloud, if I have different clouds in my different stages, it's not a problem. It's just at the level of deployment automation. I will choose a different target environment, but my microservices will be the same and my pipeline will be the same, and so on. So what does it mean, decouple deployment automation, environment management, and the pipeline? It means be able to model what happens in terms of building the microservices. I will show you in 1 minute, what it means more in details. But so have a model of the application, have a model of the environment. So what is the target? We will deploy this towards that, knowing that my Kubernetes cluster, for example, here could be located on AWS or Google. It's not necessarily my problem when I'm developing and when I'm designing my microservice or my container. Okay. On the other hand, what is decoupled is the pipeline itself. So the different activities. The first one being building, for example, with Jenkins or with whatever we need to build. Each of my stages has a deploy phase where I will deploy my 1, 2, 100, 5,000 microservices into the target that I have defined. So what does it mean if I show you in the real life? I would say how it works. Let's go for something which I find very useful when it comes to digital transformation and how to manage these microservices. The first thing I find useful is to have this discovery, okay? Discovery on Kubernetes, typically, discovery on OpenShift, discovery that allows me to query the real-time cluster and to get what is running on that cluster. So the discovery can allow me to onboard what is existing, but not only. Once I have my microservice, very simple, this one, but once I have my microservice, I'm more used to work like this. So this is the code for my, the definition of my microservice. It's a container. I have the different characteristics of my container. I have the flexibility, since it's code, I can do whatever I want. So if I want to change the name, for example, I can change the name from its store backend until store Manuel, for example. So I will do that. Okay. So it should have, okay, store Manuel. I just validate that. And now on my microservices, I have a store Manuel that does the same thing. So I can, from one microservice, initialize other microservices depending on my needs. Maybe more interesting thing, the notion of reaching the templatization of my microservices. Here I have a microservice API component that uses a quite complex process to build and to deploy. So just having a look at the process to build, I have to make it much bigger. Okay, so I'm building with Jenkins. The Jenkins pipeline I'm using here is doing also a sonar analysis. So I get the sonar results, and I will be able to store everything in my software delivery repository, where I know exactly for each version of my code, for each version of my built container, what were the results of Sonar, what were the results of Selenium, of the different tests that I'm doing on the different stages. So it comes to, if I go back briefly to the presentation, it means that I am able to have things like this. Production report, what is installed on a specific environment. My microservices, all the information that regards my microservice, knowing that it can be management information, the one that I use to generate the next version of my microservice, but also some live information. I will show you that in just 1 minute. The one that is also, important, yes, the different comparisons between the environments, development, QA, production, where I see all the management information, what were my Sonar results for the microservices, what are the Selenium that I'm using in QA, what is the health in production. And what is the health in production comes from the fact, and I just finish on that, comes from the fact that according to my connection to the clusters and the representation I have in my repository, so I will stop it. I can have both here on the left-hand side, a representation of what is on my repository. So I have a logical environment made of applications and microservices, but I also have a real-time connection to my Kubernetes cluster that gives me all the information. So I have the namespaces, the pods, the services, the containers, until the container, which is here, with all the information. This is live information, so I can mix on that way, live information with the model I have on my software delivery repository. And this is that way that I'm able to ramp up in terms of number of microservices, managing one microservice or 10 or 5,000, as I was saying, is not more complex because I have that ability to put them all together in the same pipeline. Going back, so I left also on that presentation, I believe that the presentation will be made available, things about the value stream management. And at the end of the day, software delivery is becoming a new business function. So software delivery automation and software delivery management. So what you do and the way you do it, with all the ability to manage the pipeline, define some rules, some thresholds, all the business rules that you can apply to your software delivery. Just finishing on one slide about CloudBees, SDA and SDN. Some of you may know that CloudBees is the company that has been built upon Jenkins. We are now far, we've done a nice journey until we started with Jenkins. CloudBees CI, CloudBees CD, CloudBees feature flag, it may ring a bell. And just because my marketing wanted that slide at the very end, if you want to hear a little bit more about that DevOps world, you will see that everywhere on LinkedIn, everywhere on the web, a virtual event that will take place in September. Don't hesitate either to message me directly here or to register on the website. Thank you very much. I hope I didn't go that far in the time.
No, spot on. Thanks, Manuel, and really interesting stuff. Thank you for that. We don't have any questions live at the moment, but we'll obviously have all the details live in the next few days. If anyone has any questions for Manuel, I'm sure you'll be happy to take direct messages on LinkedIn or email, something like that. Cool. Well, thank you very much. I think we'll move on to the next talk. So Barak and Corcoran, I don't know who's sharing screen first.
I'm going to talk first. I think Barak's going to share some stuff.
Perfect. So thank you.
I'll kick off. So just thank you for the LinuxRecruit guys for giving us a slot. We've got 30 minutes, so I am going to ditch all my slideware and set my playback speed to 2 speed for everyone's enjoyment. So I'll just do a quick scene set. My name is Corcoran. I'm a solution architect with Slalom Consulting. Slalom, last couple of years, have been AWS's largest revenue generating partner. We are worldwide 8,000 plus employees, 36 offices, and we have loads of smart people, not me, other smart people, engineers, software developers, data scientists, DevOps folks, all working under the umbrella of Slalom Build, which is exactly like it sounds. So check out slalombuild.com for more info about that. So how did we get here? If I had $1 for every time someone said DevSecOps, I'd probably have $400 or $500 by now. Back in January, which historically is obviously the worst month of the year until 2020, when March and forever onwards has been the worst month of the year. I was sat in something called an office with some colleagues of mine, and we were arguing about testing Terraform with unit tests and integration tests. And to me, unit testing on unopinionated Terraform modules made very little sense because they are essentially quite static. And integration or other BDD testing in our pipelines all felt a bit like it was happening too late in the day. You know, a DevOps engineer had already written a module, the module's already in an integration layer, and everyone's too busy to notice that the S3 bucket permissions are set to public. So, right, bad. So we argued a lot in the office. I shouted shift left and DevSecOps, and people threw empty bottles of beer at me. And then I went on to DuckDuckGo, and I found this little tool sat there quietly in the wild called Chekhov from a company called Bridgecrew that no one's ever heard of. But it's some solid stuff. In January, when it was released, it was probably on a par with other Terraform and AWS static code scanning tools at the time, with 30 or so CIS benchmark type checks. And we, Slalom London, we worked with Bridgecrew quite a bit. We extended it to support Windows Desktop, yeah, boo-hiss. We added checks for GCP and GitHub, and we nagged them about private repos for very specific checks that enterprises might want to keep to themselves. And as of today, right now, I guess it has over 300 checks for AWS, Azure, serverless, GCP, and GitHub. So I'm going to stop talking and let the product do the talking and hand you over to Barak.
All right. Thank you, Corcoran. Yeah, so it's been a crazy 6 or 7 months working together with Slalom teams and with other amazing teams that have contributed to this open source project named Chekhov. And in this talk, we'll talk about the motivation of why we chose to develop that tool, where we found it useful, and also of the journey that we went together on creating a better DevSecOps or static analysis tool for infrastructure code to make cloud manifest not a par with best practices. So the problem statement is how can we make quality, secure infrastructure code manifests? As Corcoran said, those can be serverless frameworks, Kubernetes manifests, Terraform, CloudFormation, and the list goes on. And the thing is that those best practices are widely known. The CIS benchmark is one of those where you know that you should have your stuff encrypted. PCI have similar best practices, HIPAA, and other compliance benchmarks. We then force you to have all of the encryption, IAM policies, logging and auditing features in place, and have backup and recovery on each and every resource that you spin out in the cloud, whether it is AWS or any other vendor. And how can we catch that very early on without being swamped with JIRA tickets that are happening by the security team and not the DevOps team right after the fact, after the resources have been provisioned? We really want to catch this issue while developing it on our laptop. And we want to share this knowledge of security with other engineers in our team. So we came out with this open source tool named Chekhov. Bridgecrew is a cloud security company that really believes in open source tools. We have Chekhov as a static analysis for infrastructure code, and some other cool projects that I invite you to check out in our GitHub repository, like RIM for least privileged IAM, some guidelines and education tools like TerraGoat that have a lot of material on our blog too. But on Chekhov specifically, we want really to build the best testing utility for infrastructure code. Because all of those infrastructure code modules that people are writing are coming from various repositories like AWS blogs, the Terraform registry, open source GitHub, Stack Overflow question, where you typically look in Google of, hey, how should I stand up an EC2 server? And you copy it from Stack Overflow or from the Terraform documentation, and you miss the default configuration of encryption of EBS volume that is turned off. Or you miss the logging and auditing or backups of snapshots. And what we wanted to do is, hey, you have all of those open source or internal repositories of Terraform modules, as an example. And what we want to do with them is to make sure that if we use them inside our own organization or copy paste them, we we want to make sure that they are complied with those best practices. So we ask ourselves, after developing this tool, how secure is the open source world? If I'll take a random Terraform module from the wild, what's the chances that is configured correctly by default? So we run Chekhov and the Bridgecrew platform on the entire world, a lot of Terraform modules with those opinionated checks. It is important to say that writing in Terraform does not imply that you write unsecure code. On the contrary, it gives you the ability to write and define secured code in a secured infrastructure in a centralized place. What we wanted to do is to ask ourselves, are all of those default configuration really secure by default? So as a trend, we ask ourselves, how many Terraform modules are there and what's their growth? And during COVID, there have been a lot of new Terraform modules contributed to the open source, which is great. We love open source. But the thing is, as long as you write more code, you have more bugs in it. So this is the percentage of misconfigs of those common best practices that you might find on those newly contributed modules. And it's kind of crazy because more and more modules are being contributed, more bugs are being contributed, more companies are provisioning more of those modules, and they had over 10 million downloads, 56% of the 26 million downloads of those Terraform modules that are misconfigured. Those are a lot of provisioned, misconfigured EC2 instances. And those misconfigurations are in various categories. For example, backup and recovery is not always turned on. And you can understand why, because it might cost you money. But you should, if you provision in production and you copy paste a code, you want it to have backup and recovery in place. Same for auditing. Kubernetes, which is pretty new to Terraform, is not always configured correctly. And it's also obvious because it has so many knobs and switches that it's really easy to miss the security policies to be configured in the right way. Networking is usually configured good, so not a lot of open ports to the entire world, which is great. And not a lot of admins found there in the wild. And part of the work that we did with Slalom is actually to monitor their own Terraform open source modules. And they had, at the time, 41 open source repositories with millions of downloads. And together, we succeeded to move the amount of misconfigs only to 2% around logging of a service that did not require logging. And this is an amazing progress that we've done together of changing those default configuration to make sure that all the right parameters are in place. So what is Chekhov? Chekhov is a policy as code open source tool. It is version controlled. You can peer review all of those policies that you're writing. Since it's written in Python, when writing a policy, you can use inheritance. You can automate it in your software development lifecycle as part of a CI integration. And you can streamline all of those errors much early on in your development lifecycle. So let's take a look and start with a short demo. So the Bridgecrew platform is backed by this open source framework named Chekhov. It's a SaaS solution that wraps it up and adds a bunch of additional capabilities. It's very easy to sign up. You just use your Google, GitHub, or work email, hit it, and then you'll go into this onboarding screen. Whoops, click the wrong one. Where you will be able to connect your AWS, Azure, or Google account, Kubernetes cluster, and also your source control via a standard application of those marketplaces. Right after taking those integrations and putting them in place, what you will be able to do is to understand if you have issues in your infrastructure as code. So over here, as an example, I have a file of a DB application that is being stand up in this Terraform file with the default encryption turned off. And what Bridgecrew and Chekhov suggest me to do is to turn it on. And I can choose this specific resource, hit remediate, and the Bridgecrew platform will actually open a pull request that will automatically fix my infrastructure as code. So if I'll go into the TerraGoat repository, what I can see now is that I have a new pull request that was created 18 seconds ago with this encryption now turned on, which means that I can now comply with those best practices when I'm writing this infrastructure as code. As Corcoran said, there is a list of 300 different policies across the cloud providers, Kubernetes, and infrastructure manifests that can be turned off or on, and some additional ones can be easily added. You can also integrate the Bridgecrew platform with your CI/CD pipeline and have it adding comments on each and every new code that you're writing, telling you, hey, you should really not have hard-coded access keys in your code as they exist here on my Terraform block. So how would you start? You can obviously use the SaaS platform if you want a very easy onboarding. But if you want to build it in your own hands and use the open source light version of it, you can look for Chekhov. It's under Apache 2 license. It's bridgecrew.io/Chekhov at GitHub or www.chekhov.io. And the installation is pretty simple. You can use pip install Chekhov or brew, or use a Docker container to pull the latest Chekhov release. And let's take a look on how it looks like. So let's say that I've already installed Chekhov on my laptop. I have it here. When looking on the help, what I can see is that the basic parameter that it needs is a directory. Means Chekhov will require a directory to scan where you have your infrastructure as code in place. So from directory perspective, I have here two directories of two different infrastructure folders, AWS and Azure. And inside the AWS directory, I have EC2 instances, Elasticsearch, S3 buckets, and the list go on. What I'm going to try to do is take a look on how my S3 Terraform is configured. And I've written here in comments, but if I'll ignore those, I can see that I have a public read S3 bucket, and it lacks the configuration of encryption, versioning, logging, and auditing. So basically, nothing good is in place here. If someone wants the data inside this bucket, they will get it. And another example is, let's take a look on my EC2 instances that I've defined in code. I don't know, it's like a big blob of code. To go over it will take me time. I want to catch it very early on while developing and know that I have an issue. So what I can do is write Chekhov minus directory, or just -d as a short. Choose the AWS directory and ask Chekhov to scan all of my Terraform code. And it's the same command for any kind of manifest that you're having. So what Chekhov will do is it will create a CLI report where you can see all of your passing checks, the good things that you've done while writing this code. So we have here a data bucket that does not have a public write access, and that's good. A financials bucket that is also not public. That's another good job that I've done. So I'm probably doing a pretty good job as an engineer of Terraform. But here, after going over this list, here comes the bad things that I've done as an engineer, and I should really get better at this. Here I have this bucket without S3 encryption turned on. and that's the lines that are violating it. Those are the lines of this resource. And over here, I have a link to a guideline that explains to me you don't need to log in order to see those guidelines. That explains to me as an engineer the rationale behind encrypting an S3 bucket. I want to encrypt it because I don't want other users to have access to it. But if there is a user within my AWS account, the encryption is being transparent. So I have all of those misconfigs, among them also the plain text access keys that I had in my code, detected the unencrypted database that we've shown that the platform can remediate. And the list goes on and on. So how can I automatically detect those issues while developing? So Chekhov, if you go to www.chekhov.io, and after going through the installation phase, you'll take a look on a pre-commit hook configuration. You can actually configure a pre-commit hook on your workstation that will prevent you from committing new code that contains bad practices. Which means if you write Terraform code, you cannot push code that has bad practices in. But what if there is some kinds of acceptable risks? What if this bucket should actually be public because it contains website assets? What you can do is if you go into the suppressions tab, is the exact same example that is public and contains a static content. I want it to be publicly accessible. So you can have just a very similar annotation to a JUnit or Python test annotation, telling to Chekhov as the testing framework be public. Going back to how to manage Chekhov at scale, what you can do after scanning your directory and configuring a pre-commit hook, what you can do is to configure the same utility in your CI/CD pipeline. And this will look like this. Let's say a developer is pushing a change. The developer will get the code scanned for security best practices together with the unit tests. And if the unit test of security means Chekhov passes successfully, you can safely apply all of your resources into your production account. Obviously, if you want it to be out of the box, you can use the SaaS, but the open source allows you to do that too. It's more or less about Chekhov.
Lost you a bit there, but I think you're back at the end.
Sorry,
you.
Barak, we lost you a little bit at the end there, but thanks. Is all wrapped up?
Yes, thank you.
Thank you very much. Yeah, really interesting stuff again. Obviously, in the chat there, all the links that you need to have a look at the stuff on GitHub and things like that. And again, if anyone's got any questions, because we don't have any live in the chat still, yeah, we can kind of put all the details for you to answer that in the next few days if anyone's interested. Thank you very much. So yeah, on to the last talk. I think Christine's there still, hopefully.
Yep, sure am. Let's see what we can do here. All right. So this should be a kind of nice light one for everyone. I guess quick backgrounds. My name is Christian McHugh. I've been doing DevOps-y type stuff for an awfully long time now. I don't happen to work for Salt or any of the companies that I'll be talking about their products for. I'm just kind of talking about a situation that we ran into and what we did about it. And I thought it would be might be useful for folks. So we can go through it. So I'd like to at least review the tool selection of how we ended up where we were, a little bit of background about SaltStack, what you guys probably might know as a configuration management tool, and its architecture a little bit, because that will inform a little bit more about what we're about to discuss. Go through a little bit of a problem statement and then kind of our solution there. So in the configuration management world, the main big players are usually Chef, Puppet, SaltStack, and Ansible. And I would say in general, I don't really care which one you use. It doesn't matter. It's use one of these things, make sure that one of these things works well in your environment. And I think that last bit is absolutely key. As we've kind of had a pattern of the speakers talking today about the level of complexity and trying to manage complexity. So how do you validate your environments? How do you check that your environments are doing the things they're supposed to be doing? How do you manage all of that, the tool sprawl and complexity? And when I had an experience years ago working for a firm where we were trying to introduce a configuration management tool. We went through our requirements list and we said, okay, yep, Chef's the one we're going to use. That's going to be great. Everyone's going to use Chef. We picked it. It meets all these check boxes. Good to go. And we went to roll out that tool. And in the process of doing that, we had a dedicated servers team that managed the infrastructure and the OS management for the firm. And that servers team was kind of a bunch of folks who had been doing Linux, Solaris, AX administration for an awful long time. And so when they were going through the Chef training and having to go through use of that tool, we kind of had a rebellion on our hands where that team came back to us and went, well, everybody, it's not going to work. We're Unix admins, we manage config files, and you're having us be Ruby programmers. We don't like it. We're not going to do it. And so we actually ended up going back to the drawing board and going adding more stuff into kind of our requirements gathering and finding out that the usability of the tool wasn't right for that particular place. And so at the time we ended up deploying Salt because it used a slightly easier to get into YAML and Jinja syntax, and our team was more willing to get into that, and that they felt it was more like a configuration file that they were able to edit. And so all of the stuff I'm about to discuss with everyone, just keep in mind that this isn't a silver bullet. None of this stuff is, you just do it like this, everything's fine. It really comes down to what works well for your environment, for the people that you have, for the skills that they have, for the knowledge that they have, and your ability to maintain all of that. So let's get into it a little bit. SaltStack as a configuration management tool, it's often put into the configuration management bucket, but it's actually significantly more, and I would argue significantly different. It's ultimately around remote execution. And its remote execution story is pretty good in that it can manage thousands of hosts pretty easily. And so in doing that, it also can manage the configuration of those hosts, because ultimately configuration management is capable of being kind of a subset of the remote execution problem. And so the primary way that you would use Salt is that you'd have an agent, or what they call a minion, that lives on a server someplace. And then that minion checks into a Salt master, and there's a pub subscribe bus that runs that master, and ultimately communication flows. That minion is constantly checked into your infrastructure, and that gives you the very powerful ability to reach out and touch stuff ad hoc and at scale. And so if you're trying to do something like secrets management, where you're trying to distribute secrets into your environment, some passwords or whatever, you often end up with a day zero management problem of how can I verify that the node that's asking for the secret is the node that I think they are. And because Salt has this encrypted channel, if you set up Salt in your environment properly, you get kind of secrets management out of that for free. You already know who's in your infrastructure. You know what those machines are. They're kind of, you've already handled that problem. And so it ends up being a pretty good Swiss Army knife. And so I'm going to get into kind of how we Swiss Army knifed it. So as described, we have you can have a Salt master, you can have some hosts out there, and all of that stuff is connected. It all works out pretty well. Another component of how Salt is capable of working is that you can have what they call proxy minions. And so what I was just talking about works really well if you control the OS. And so if you're able to install a minion onto that host, that minion can talk into the Salt master and everything talks, and it's fine. You can manage that thing through Salt. It's easy enough. But if you have, say, network switches out there that you're not able to install random bits of software on, well, there's a slightly different pattern for how you might work that stuff. And so there, Salt has an architecture where you have what's called a proxy minion. And so that can be running on a VM or as a Docker container or whatever. And its whole job is to be an endpoint on the network that when it's called through the standard Salt mechanisms, that it then reaches out and talks to whatever infrastructure it needs to through whatever API or process that might be. So for some networking gear, it SSHs in and does the CLI commands thing that it has to do. For an awful lot of stuff, it's more leveraging some of the network libraries and uses their APIs and so on. So great, you can manage all that stuff. And there's also a bunch of other ways you are capable of running Salt. You can have it run through cron and just be an ad hoc job that runs nightly or whatever, but that's not the really interesting stuff that I really want to talk about. So great. So the kind of advantage of Salt and its whole backend is that it has a ridiculously modular code base. So you don't have to wait for a new release of Salt to get some functionality in there. You can actually more or less backport a bunch of that module that you might need that's in the future release, or you can write your own and just put it into your Git repo, and Salt will just use that one instead of its default one, that type of thing. So Salt has what are called execution modules. And in just looking it up for this talk, it turns out there's 531 of them right now, which is an awful lot. And so those are the things that you would run on the command line. So if you SSH into your Salt master, you can target some host and say, host A, tell me about the status of this file. So it could be, tell me about the permissions of it, make sure the files, write this text to this file. You kind of have your building blocks of listing, adding, modifying things. If you want to deal with users, for example, you'd have a users execution module, which will let you add or list or manage users. So great, you have those capabilities on the command line, and that's a way that you could just reach out and touch your infrastructure. And you can do that just as easily on one host as 1,000 hosts. It's pretty nice that way. There's also a component called state modules. And if anyone out there has used Salt Stack before, that's probably most of what you're dealing with is running states on hosts. And those are very similar to the first group, only they manage state. They're little state engines. And so they often use the components that we just discussed. And so if you want to say, ensure that a user account is present on a host, you would run the user states, which would say, ensure that this user is present and have all of your options and arguments and so on of how you want that user configured. And that user state would then probably leverage the user execution module to see, well, is the user already on this host? If it's not, let's add it. If it's already there, then it can return back that it doesn't need to do anything more. If it is there, but it has some different attributes or whatever, it can make sure that those things get modified, return back the results and so on. And so in my experience in working around Salt, it's been kind of nice because a lot of the problems that we've run into end up being tiny state management problems often in your infrastructure. I just want to ensure that things in the state that I expect it to be in. And so if that's some switch out there or a load balancer or an OS, then Salt gives us kind of this modular architecture to be able to manage those things pretty well. So that's all pretty neat. And then the last big bit of what I would like to discuss really briefly is just that Salt also has different rendering modules. And so when you write some YAML and Jinja that Salt executes on, then that's being run through the renderer. It first runs through the Jinja renderer, and then it will hand it off to the YAML one. And then what gets handed off to Salt is just some Python objects internally. And so that's really nice because they're pluggable. And so if you really hate YAML and Jinja, cool, use Mako or just write it in pure Python if you want. So you have a lot of options there. And so the Salt backend doesn't really care. If you have a render module that speaks that language, it can use it. So that's just pretty nice. In general, folks just tend to stick around YAML and Jinja though. And there's a bunch more. So you can do stuff with auth and external data sources and pulling variables from various places and all kinds of cool stuff, but that's not the purpose of this talk. So I mentioned that YAML and Jinja are typically used, and so this is an example of what that kind of looks like. So at the top here, we're managing a file, and we're pushing out this http.conf, and we're ensuring that it's got these permissions and so on. And we have a source where that thing's coming from. So that's your standard configuration management kind of look. If you're using Ansible, it would look nearly identical to this, very close. At the bottom, there's a slightly more advanced version where syntax highlighting for Jinja tends to go kind of crazy. And in this case, we have a templated version of something doing something kind of similar. So we're pushing out the message of the day file, the MOTD, and we have a little bit of logic in here to determine where that file is coming from, or to loop over it a couple of times, or whatever it is we have to do. So in general, this is the type of thing that your sysadmin teams would hopefully be pretty familiar with this day and age, that they're able to do this type of thing pretty easily. So great. I mentioned that the whole purpose of this talk was to talk about a problem that we had and what we did with it. And so our solution here ended up being a thing called Saltcheck. And so Saltcheck is just a salt execution module. And so you can, like I said, target anything in your environment. So you can say all hosts that are running this role within the dev environment, I want you to run the Saltcheck validations to run the instruction sets, whatever they are. And so if you run what Salt calls a high states, the be in the state you're supposed to be in, run all of the instructions you're supposed to run to be that host, then Saltcheck can say, well, run all the tests associated with all of those states that we've assigned to that host. Likewise, you could also just say run a single test or whatever. And so that's pretty neat. And the way Saltcheck works is that it just runs one of those Salt execution modules. And so you have all of the power and capabilities of whatever Salt wrote an execution module for, you are able to validate that thing's output. And so to use the user example from earlier, if you wanted to see, well, I should have added 1,000 users and these SSH keys to all of these hosts, did it get done properly? So Salt said it did, and it came back and said everything's okay, but maybe you want to double check and validate that. And so Saltcheck can be used to do that kind of job. You can just have a little test script that says, see if the user module returns back the information that I expect it to have. But the really nice thing about it is that it uses the Salt rendering system. So that YAML Jinja stuff that your sysadmin teams might be familiar with, it uses that language already just the same way. So if you happen to be a Salt shop already, then Saltcheck makes it pretty easy to start using that thing too. Salt has the concept of variables on a host. It calls them grains. It's kind of like variables from Ansible or the OHI stuff or from Chef, but just the information about a host that you can also be appended. You have access to all of that stuff in Saltcheck as well, or your external data sources, or those secrets that Salt's managing. So it's just being able to leverage the power of this fairly rich ecosystem means that you can do a bunch of stuff. So those tests end up looking something like this. This is a short, simple version, but it's pretty similar to the Jinja YAML stuff we were looking at a little bit ago. So at the top here is an example of just a simple check where we're going to run the package.upgradeAvailable execution module. And we're going to pass along the Apache 2 arguments. So this would be a Debian host, it looks like. And so we can see, does my Apache 2 package have any updates available? And we're going to run an assertion here and say, well, it shouldn't, otherwise the test should fail. And so that's a pretty quick test to see, is there a security update or whatever for my Apache package? And likewise, down at the bottom there, there's a fairly equivalent one of checking Apache 2 and OpenSSH. And we're doing that in a Jinja for loop just to test multiple things. And just the demonstration here is just showing off that the YAML works in the top one and the YAML plus Jinja work in the bottom case. And at the very top there, that's an example of the command line that you might run to test some of your stuff. And so the Salt command line looks something sort of like that. That would target all the hosts in your environment and say, run all the tests associated with your environment. So great. So now the problem that we had was we had environments where we were spinning up these very large Hadoop clusters on a regular basis. So we had our production environment, we had our QA environments, we had various UAT environments, we had a lot of dev environments. And for something like Hadoop, it's capable of being incredibly complicated. And so the problem we ran into was whenever we changed some stuff in our environments, maybe that was our AWS provisioning code that we were doing in Terraform, or maybe it was some sort of ACL bits we were doing to change how we were securing our data sets, or we were uploading new versions of data sets or new code or whatever. All of that stuff, it's just a ton of things that you have to manage and track, and it gets really complicated. And in a really large development shop, when you're trying to manage a lot of things between a lot of teams, there's a lot of friction between all of those teams. And so the problem that we had was really that there was a lot of change happening. That change was hard to manage. We had a dedicated QA team, but the QA team effectively couldn't really keep up very well. That whenever we provisioned one of these clusters and there was a problem, the QA team had to get on it and they had to run through the same script every time. And so they had to check, is this Hadoop file been provisioned properly? Is this config file been provisioned properly? Are these users in the right state? Are the various mount points accessed appropriately? Are these network ports open between these nodes and the clusters? Is this database available? Are these other AWS endpoints provisioned correctly for this one environment versus this other environment? And so all of those special edge cases and features and all the stuff that they had to deal with just ended up burying them. And so it just took them a ton of time to be able to validate these clusters. And if you're spinning them up regularly, you don't really want to spend time having that team get buried, and it's not really a good experience for anyone. And so as an example, we had problems with some of the things that I mentioned here: user management, data state, network connectivity, all the big, I provisioned a big cluster kind of issues. And so our solution there was we wanted to be able to save them time. And so we ended up deploying Saltcheck, the thing I've luckily been talking to you about all this time. So great. Here's a fairly short example of what one of those Saltcheck tests might have looked like for our Hadoop cluster. So there happens to be a Salt execution module for Hadoop and the Hadoop file system backends that it has. So there's this Hadoop DFS present reports back if that file exists within the Hadoop file system. And so we can pass along a particular file where that file has some variables that come from some external data source. So depending on how we provision that cluster, they would have different versions of things. Those versions of things we saved in the Salt grains, the variables that we kept on the hosts that Salt had access to. And in that way, we had a really, this ended up being a really good solution for us where it was really cohesive. We could have our provisioning code do the provisioning process. It managed this thing pretty well. And for our QA teams that had to validate, are all of these things okay, they were able to write some of the tests like this. Or at the very least, they were able to describe what their tests should be. And the sysadmins who were familiar with this environment were able to write these tests without too much of a problem. And that's really the secret sauce, I think, behind a lot of this stuff, because we end up with a lot of different tools and there's a lot of different options that you have out there. There's a lot of different ways that infrastructure can go. And you need to make sure that you're doing a thing that's maintainable for you all in the long run. And so what was really advantageous for us is kind of like my chef example from the very beginning. We were able to leverage the existing nomenclature and syntax that a lot of our teams were familiar with in order to use those tools even more than what we originally intended for them to be used for. So it was nice in that it reduced our maintenance burden. So here's an example of talking to a Hadoop file system backend. Likewise, we can test the contents of the Hadoop files themselves. This would be slightly complicated to do just in a shell script or something. And so here we can use the Hadoop DFS, Hadoop.dfs to output the text of the file and then do an assert not in. And so this is a way that we are able to validate this one config file to see, is it in its default state? Has it not been provisioned? Is there some issue with the config file that it should never be in this state? So hopefully that never occurs, but it's a quick validation just to check that one off the list and go, nope, we know that that one's okay, move on to the next potential problem. Likewise, you can do some user management stuff. So here's an example of iterating over our external data source, which is this pillar.get thing at the very top. And so there's some place that we kept a list of users. That could be S3, it could be a Git repos, whatever it was. But we kept user information that we wanted to provision to our environments. And so we had a list of users, SSH keys that should be associated with them, and so on. And so this is a check that is nice because it's integrated into Salt the way that it is. It allows us to use those same Salt components and backends. So in this case, the same place where we kept, here's the list of users that should be provisioned, we're able to take that same list and then validate against it. So again, reuse of the tool, we didn't have to rewrite the export of that data to run our checks later. We can also do things like check S3 and validate that our data is in the state we expect it to be in, ensure that the files are there, they contain the right things. You can just full on run commands if you ever need to. And so in this case, we're running a Python executable just to validate that the Boto3 library is in the installation state that it's supposed to be and so on. So the power is really up to you, and that whatever you need to do, you have a lot of capabilities out there to get it done. The other component of all of this, I guess, is in my experience, you often want to centralize or control the places where you invoke change. And so Salt, being the excellent remote execution tool, makes that pretty nice. And that we could say, anything that gets adjusted on that host has to go through this path. So if we're going to say deploy files and restart services, then we would just have a deployment state and push that out to our host as we needed to. We'd have the initial build of hosts and do the classic configuration management story. Likewise, a lot of this stuff can be tied into Jenkins. And so we use Jenkins quite heavily in that shop for our deployments and CI pipelines. And so as part of that, we would have examples sort of like this, where this is an example of using the Salt plugin for Jenkins. I guess, quick aside, I happens to be the author of that. So if there's any problems, please fill out bug reports and so on. But we were able to use this pretty nicely in that we could have Jenkins do whatever build job it wanted to do. And when it came to deployment time, it could kick out to our external agent of change, the Salt, in this case, Salt API, and make sure that that state got deployed and that application got deployed utilizing Salt states. And then the bottom line there is just running a Saltcheck run test against it as well. And so as part of our CI pipeline, we could both deploy the thing and validate a bunch of stuff about our environment utilizing the same suite of tools that we're already comfortable and familiar with. And so again, just try to reduce your maintenance burden as much as possible. So overall, as a summary, Saltcheck was able to, we were able to leverage remote capabilities of it so that we were able to reach out and touch infrastructure, some of which would have been really difficult for us to do otherwise. And it was important that we were able to utilize this tool in particular because it kept the same familiar markup and the same data sources. Overall, you want to have a pattern of just reuse and knowledge reuse and sharing kind of design patterns. You don't want to have every team necessarily invoke their own special snowflake every time, so that when you're trying to introduce that team introduce, say, standards around monitoring or deployments or configuration, you want to make sure that those things are done in a way that everyone kind of understands them, even if they don't understand everything about the tool, that they're at least familiar with these patterns and designs. And so leveraging Saltcheck in this case allowed us to do that type of thing. It made it easier for us to get through this, this validation problem that we had. And overall, kind of echoing what some of the previous presenters have been speaking about as well, having been doing this computer gig for a while, we're not getting any, we're not getting any less specialized. That the IT world is forever becoming more and more specialized in language choice or build chains or deployment topologies or server methodologies, and just everything about this industry is larger than it ever has been before. There's more stuff to learn like never before, and you have a benefits of so many riches out there of what to choose. And so overall, I'm not saying everyone out there has to use Saltcheck. That's not really the important bit. It's utilize something that your team understands. That's the hardest part. That everyone can go out there and read a blog post and go, oh, here's the cool new shiny thing. This thing's awesome for these reasons. And ultimately, it all comes down to what can you support for your customer base and how effective can you be? And so in general, we all have teams with limited resources, limited capacity to learn yet another thing. So just try to leverage your existing skills, your existing knowledge to be able to get through all the maintenance that you'll have in this massive tool sprawl. So for us, Saltcheck ended up being a really useful tool, really helped with validation for all the reasons that I mentioned. It may or may not be good for you, but I figured it was at least worth a look and worth the conversation. So that's all I've got. Thanks very much.